to find the LCM, which is the least common multiple, we're going to be counting up. Multiple means like to multiply up. So if I'm finding the least common multiple of 5 and 3, I'm going to count up by 5s, and then I'm going to count up by 3s until I get to a common number. Do I have a common number yet, Kate?
Yes, it's 15.
Yeah, so I'm going to circle 15, and that is my least common multiple. My greatest common factor is also called a GCF. So if I have the numbers 30 and 15, the factor means that I'm dividing. I'm finding out what divides into 30. So I'm always going to start with 1, and I'm going to go through all the numbers. So does 1 go into it? Yes. Does 2? Yes. Does 3? Yes. How about 4? No. 5? Yes. 6? Yes.
Yeah.
7? No. 8? No. 9? No. 10? Yes. And you can take your time with this. It may take you longer. Totally fine. 11, no. 12, no. 13, no. 14, no. 15, yes. And then as soon as I get to the halfway point, 30 and 15, right? 15 is half of 30. I can close it out with the number that I started with. And then do you remember each one of these has to have a match? So we make a rainbow to make sure they all have a match. Then we do the same thing to 15. Does 1 go into it? Yes. Does 2? No. Does 3? Yes. How about 4? No. 5? Yes. 6? No. 7? No. We're halfway point. Now we close it off and we make sure that we have a matching number. So I call that a rainbow. Make sense to you so far? Okay. Now we're going to find the number, the greatest number that they have in common. So they both have a 1, they both have a 3, they both have a 5, but I'm looking for the greatest common factor, which is 15. Okay. When we write a plain old number, it's called standard form. So 5,362 is already in standard form. Expanded form means that we take each number, each digit, and we tell the person looking at our page what this 5 is worth. So what is the 5 worth? 5,000. How about the 3? 300. The 6? 60. And the 2 is worth 2. And then word form means that we spell it out. So we're going to do 5,362. Okay, any questions about that, Miss Kate?
No.
Okay. Prime factorization means that we take a number like 50 and we find two numbers that go into it to divide into it. So we can pick 2 and 25, 5 and 10. Doesn't matter what number you pick. So I'm going to pick 5 and 10. And I keep finding the factors until I get to a prime number. Do you remember what a prime number is, Kate?
1. Prime? No, I don't.
So every number is either a prime number or a composite number. A prime number means that it only has two factors that divide into it, 1 and itself. A composite means that it has 3 or more numbers that divide into it. So if I were to try to find the factors of 5, I would only be able to do 1 and 5. Is that correct? There's no other numbers. 2 doesn't divide into it. 3 doesn't divide into it. So as soon as I get to a prime number, I circle it. Does that make sense to you now?
Yeah, I just forgot what it was called, but I know how to do it.
Okay. And then this one, I have more factors, so I'm going to say 2 and 5. And then I'm going to circle 2 and 5 because no other numbers go into 2 and 5. Now I'm going to list them least to greatest. 2 times 5 times 5. Remember, this right here stands for multiplication. When it's up here, if it was here, it's a decimal. But in the middle like this, it stands for multiplication. And you can either write it like this or you can write it like this. It means the same exact thing. All right, we are going to go over place value. So this is the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. Once I put my decimal here, now we have the tenths place. Then I have the hundredths place. So it has a TH at the end of it. Tenths, hundredths. And then this one would be thousand with a TH at the end of it. Thousandths. Does that make sense to you?
Yes.
Awesome. Okay, when we're adding decimals, we're going to, number 1, line up the decimals. Not the digits, but the decimals. So this problem is going to look like this. And then that looks kind of weird, right? So I just add zeros, and then I do my adding like normal. And my decimal stays exactly in line. Does that make sense to you?
Yes.
Beautiful. Okay, I'm going to change colors here. Subtracting fractions, you would do the same exact thing. We are going to line the digits up, fill in with zeros, and then subtract like normal. All right. When I'm multiplying digits, I'm not going to line up the decimals. I'm going to line up the digits. So that's important to remember. For these two, you line up the decimals. And then for multiplication, you're going to line up the digits. So if I had 3.62 times 0.31, you see how this, it happens to be lined up, but suppose it was like this. I would not line up the decimals, I'm lining up the digits. Okay, so step 1 is to just do your regular old multiplication. And then add. And now we count from the back. How many jumps does my decimal go in here? 1, 2. And then this one is 1, 2. So we're going to add this up. This is 4 jumps, right? So I'm going to put in my imaginary decimal here, and I'm going to go over 1, 2, 3, 4 jumps. So this number becomes 1.122